Hello everyone. In this video, we are going to discuss about analytic function. A complex function fz which is differentiable at point z is equal to z0 and also differentiable at every point in the neighborhood of a point z0, then the function fz is said to be analytic function. So it's clearly related to its differentiability. Now, there is a point z is equal to z0 where the function fz fails to be analytic. Then this point is said to be singular point or singularity of fz. So we have discussed what is analytic function and what is its singularity. Let u and v are two functions of xy like this. Then u plus iv be complex function fz. This function is said to be analytic function if it satisfies a necessary condition, which is partial differentiation of u with respect to x should be equal to partial differentiation of v with respect to y, and partial differentiation of u by with respect to y is equal to minus del v upon del x. This is the necessary condition for a function to be analytic, and this equation is known as CR equation. In short, actually it is Cauchy-Riemann equation. This is very important equation. It is going to solve all your questions. So you have to learn it. It's very easy. Now let's move forward. In polar form, complex function fz is written as u, which is function of r and theta, plus iv, which is again function of r and theta. So in this case, CR equation will be del u upon del r is equal to 1 upon r del v upon del theta, and del u upon del theta is equal to minus r del v upon del r. Now let's talk about harmonic function. So if fz is equal to u plus iv is analytic, then its real and imaginary, both the parts will satisfy Laplace equation. So we'll get del 2u by del x squared plus is equal to 0, and similarly double partial differentiation of v with respect to x plus, again this will be 0. So both u and v will be harmonic function, and hence u and v are harmonic conjugate of each other. Guys, remember this term, harmonic conjugate. U is harmonic conjugate of v and v is harmonic conjugate of u. Okay, so now we are going to know some of its properties, like if fz and gz are already analytic, then fz plus minus z would also be analytic. Fz into gz will also be analytic. Fz upon gz or gz upon fz will also be analytic, given that in this case fz should not be 0 and in this case gz should not be 0. So now next property, fz is differentiable and continuous if it is analytic. This is very simple, and the derivative of fz is also analytic if fz is analytic. So the next property is if fz is defined as u plus iv and is analytic, then let us assume C1 be the family of curves defined by uxy and C2 be the family of curves defined by vxy. Then C1 and C2 will form orthogonal system, which means they both cut each other at 90 degree. Okay, now let us consider fz be an analytic function of u and v, and u is given to you and you have to find v. Then what you are going to do? Then we are going to use total differential method. So in this method, what we are going to do? Step 1. First we are going to find del u by del x, which is partial differentiation of u with respect to x, which we'll now write as this, and find del u by del y. Now step 2. In this, consider this equation dv is equal to vx dx plus vy dy, and now we are going to replace vx and vy by ux and ui using CR equation. Then this will become minus uy dx plus ux dy. In third step, we are going to integrate dv in order to get v, which is equal to integration of minus uy dx plus integration of ux dy and a constant c. So here vxy is the required harmonic conjugate of uxy. And similarly, you can find uxy using v. Let's take an example. Vxy is given by y square minus x square, and you have to find uxy. So I have told you how to find v when u is given, and now by this example I'm going to tell you how you can find u by using v. So first find vx and vy. So vx is del v upon del x is defined as minus 2x, and vy is del v upon del y, which is 2y. Now first we consider that equation. Du is equal to ux dx plus uy dy. And now using CR equation, we'll write vy dx minus vx dy. So putting the values from this and this equation, we will get 2y dx plus 2x dy, which will be equal to d2xy. Because after differentiating this equation, we'll get equation like this. So now clearly u is equal to integration of du plus c, which is a constant. So 2xy plus c is the value of u. This is how you're going to find u. and similarly v. Okay, now we are going to find fz when only u is given. So step 1 in this case would be differentiating fz, which is f dash z, which is equal to ux plus ivx. We are going to differentiate f with respect to x. And then by using CR equation, we will write fux minus iuy. Then in step 2, we are going to replace x by z and y by 0. And then our function will become let gz. So now fz is equal to integration of gz with respect to z and plus c. Here c is complex integral constant whose value will be like c1 plus ic2. So this is how you will find fz. And similarly, when vxy is given, then you're again going to differentiate fz with respect to x like this. And again using CR equation, you will get vy plus ivx. And then in step 2 again you will replace x by z, y by 0, and then f dash z will become gz, and again the whole process is same. So this is how you're going to find analytic function fz when either u or v is given. So let's take another example when u is given as half log x square plus y square. It is the real part of fz, and now you have to find fz. So by using the method which I have told earlier, f dash z is equal to ux minus iuy, and ux is equal to differentiating this with respect to x would be x upon x square plus y square, and uy will be y x square plus y square. So we are going to put this and this in this equation. So f dash z becomes x upon x square plus y square minus iy x square plus y square. Now we are going to replace x by z and y by 0. So gz is equal to z upon z square plus obviously 0, so we are going to ignore this, and this minus I, this is again 0, so whole thing will be 0. So we are left with z upon z square, which is nothing else but 1 upon z. And now fz is equal to integration of gz plus c. 1 upon z's integration is nothing else but log z plus c. So this is how we find fz using uxy. Let's take another example. Here the real part of the analytic function uxy is given, which is ex into x cos y minus y sin y. And now you have to find fz. So first we find ux, which is ex cos y plus ex x cos y minus y sin y, and then uy will be e to the power x minus x sin y minus sin y minus y cos y. Now replace x by z and y by 0. So ux is equal to z is z plus e to power z, which is nothing but e to power z, z plus 1, and uy will be 0. So f dash z is equal to ux plus I Vx, which is equal to ux minus I uy using CR, Cauchy-Riemann equation. Then this will become Ez z plus 1. So our required function fz is equal to integration of e to the power z into z plus 1 plus c. Again, see, this c is complex integral constant. Don't forget this. After integrating this, you will get z e to the power z plus c. So this was all about analytic function, how you will find fz when u or v is given, and how to find u when v is given and v when u is given. Thank you.